How to perform factor analysis using SPSS. I will take a few minutes to go through the basics of the theoretical concept of factor analysis. Now, what is factor analysis? Factor analysis is a dimensional reduction procedure. By that, I mean it's an analysis procedure where you have a lot of factors, whether observed or unobserved, and you want to reduce it to a parsimonious construct where you have only few predictors or independent variables. So what FA actually turns into a fewer number of dimensions, and particularly if you want to run a regression analysis and you have so many independent variables or your predictor variables, you can actually use factor analysis to reduce those variables into the most important ones for your analysis. Now, for you to run factor analysis, you have many estimation procedures that you can use. We have what we call the principal component analysis, we have the principal axis, and so on and so forth. But we'll do this in the software, so there's no need for me to go into the intricacies of all this. But I'll explain to us why we use these two principal component and principal axis factoring procedure, as we'll get to see in the presentation. Of particular interest to us today is exploratory factor analysis. That is what we'll be focusing on today, because in most cases, this is the genesis of analysis. Simply helps us to explore the imposing any prior model restrictions on it. So invariably, we use EFA when we have little or no knowledge on the factors or indicators in our data set, and we want to discover which variables or factors or patterns and relationships exist within the data set. So that is the essence of exploratory, as the name implies. We want to explore these patterns, these trends, these relationships. That is the essence of EFA. Confirmatory factor analysis, on the other hand, is more of a hypothesis testing procedure, meaning that theoretically and empirically, you've established your model. So you want to test how well your data fit this model. Now, when you're running structural equation modeling, usually you would use what we call confirmatory factor analysis. That is why when you're stating your hypothesis, it's expected that your variables, the relationships are well grounded in existing literature, so that you can use the structural equation model to confirm the stated hypothesis. In that way, you're able to get the validity and reliability of the hypothesis that you're testing. So the basic differences between EFA and CFA are, firstly, it has to do with the direction of the analysis. What do you want to do? Are you trying to generate hypotheses from the data, or are you trying to confirm existing hypotheses using your data to test a model? So depending on either of them. Another difference between EFA and CFA has to do with the number of factors you can extract. Now, in exploratory factor analysis, you can determine the number of factors yourself. Like the eigenvalues greater than one rule is the Ebo rule in script plot, and then you can also look at the proportion of variance explained by the extracted variables. It's based on theoretical or empirical, so you may not have a lot of flexibility when it comes to doing that. Even though during the analysis you can, but then it's not really the ideal thing to do. Another major difference between them is the factors, whereas you can do that better, so don't worry about the grammar. Give a more meaningful and parsimonious solution, a model in which you have very few predictive variables. So your independent variables, you want them to be as few as possible in the model, while they account for a significant proportion in the dependent variable. So I did mention that in EFA, you can do what we call factor rotation. So there are many ways of doing this factor rotation, depending on the study design. First one is what we call the orthogonal rotations. In orthogonal rotation, you have restrictions on the correlation between the factors. And you can use your Varimax or Equimax rotation procedures to do that. Then the other one is what we call the oblique rotations, which allows the factors to be correlated with one another. An example of that is a Promax. It is very important for us to know that both exploratory factor analysis and confirmatory factor analysis are not mutually exclusive, meaning we can use both of them hand in hand. They can complement each other. So we may need to combine them in a sequential or iterative way. For instance, if we can decide to first use EFA to explore our data, and then we'll generate a temporary model. Subsequently, we then use the confirmatory factor analysis to confirm or refine the model to improve its robustness. Another thing we can do in a reverse order is to use CFA to test our model. Then if we discover that there are some problems or discrepancies in the model, then we can go back to exploratory factor analysis to modify this and then improve the robustness of our model. So they are not mutually exclusive. We can use them together. Now, the most important considerations, because every other thing I've mentioned so far, the software is going to help us from most of them, but please pay attention to this part as it has to do with the study design. Very important. Always remember that your design is more important than the analysis. For you to run a reliable and valid factor analysis, you need a sample size of at least 300. And that has been established by previous researchers. You need a sample size of at least 300 respondents. 500 is very good, and 1,000 and above would be considered to be excellent sample size. And of course, the size alone is not the predictor of a good sample. How you collected the data also matters. The representativeness of your data also matters. Now, having determined the sample size, there's something we call the Kaiser-Meyer-Oakley measure of sampling adequacy. It's statistics that is generated by the SPSS software, and it's one of the first things you consider. Generally, you would expect your KMO value 0.6 and above. This is 0.6, please, 0.6 and above. So before you proceed to run your factor analysis, first of all, your sample size must be up to 300. Secondly, you have to check your KMO value. It has to be at least 0.6 to ensure that your sampling is adequate. Then the next thing you have to check is what we call the Bartlett's test of sphericity. So what this test does is to test the hypothesis that the correlation matrix is not an identity matrix. If we've done matrices, an identity matrix is simply a matrix in which you have the elements on the diagonals to be 1 and then 0 elsewhere. So that is, so before you proceed to run your factor analysis or to even explain anything in the model, you have to consider this first. That's what we are going to consider. Now, the next thing is, excuse me, I was taking a cough. Okay, so ideally, we would want to reject the null hypothesis when we look at the Bartlett's test of sphericity. Don't worry about the grammar. SPSS generates all this output for you. All you have to do is to have this basic knowledge, and then you would be able to interpret your outcomes accurately. So now, interesting part of our work is running the analysis, because that's why we are here. We all have the practice data for week 3, and we are going to use that data to perform factor analysis. And what is the objective of this analysis? We want to identify the salient factors influencing people to work in the informal sector. That is the objective of this analysis. You know, people choose to work in the informal sector, especially in developing countries. And sometimes you ask somebody, are you a graduate? Yes. So why are you doing your own business? There could be so many reasons for that. So we want to demonstrate factor analysis based on these objectives. So please, let's launch our SPSS data. Someone can share the data in the chat group. Some are not having it, please. Someone can share the data. Some people are not having the data. Let me see if I can share. No, I can't log in now. I can't do that. Someone should share the data, please. Some are not having the data. Okay, so assuming we have the data set, I want to go to the data set in my SPSS. Please